Welcome to part 3 of our rational expressions work. Okay, adding and subtracting rational expressions. So add the following rational expressions. Okay, well the good thing about this is they have the same denominator. You can only add or subtract them if they have the same denominator, just like with fractions. So these have the same denominator, so we will keep it 2p plus 7, they have the same. And we will add the numerators. So we will add this plus this, which in this case is 7p plus 5. Now neither one of those factor any of that, so we can't worry about simplifying, but there's what we've got. It's simple enough. If we have the same denominator, we just combine them. Now subtracting, well, I'm going to write this as an extra step. I'll keep our same denominator, but it will be 8y minus 16. Now I noticed something right here. Actually, the top numerator simplifies. We can factor that as 8 and y minus 2. And then our y minus 2 will cancel to make 8. Okay, so the idea here is same denominator, get the same denominator, add or subtract our numerators, okay, and then simplify if you can to reduce that. It's kind of the logical flow we've got here. Subtract the rational expressions. Okay, well, they have the same denominator. We have to check that. Because they have the same denominator, we can combine them. Y squared plus 3y minus 10. Subtracting those, we get 3y minus 6. Numerator, a 3 comes out, so we get 3 times y minus 2. And the denominator, I believe that's going to be y, the 2 and a 5, a positive 5, and a negative 2, which then reduces. The y minus 2's cancel. 3 over y plus 5. And that will be our final answer. And of course, always pause. If you need to go back, you can do that. That's the beauty of a video. Alright, so pause it, try these, and see how far you get. That will be 5n plus 7 over n plus 3. Hopefully that's what you got. And for number 2, y squared minus 4y over y minus 4, which factors. Y comes out to be y times y minus 4 for y minus 4. The y minus 4's cancel out, and our answer is just y. Next one for you to try. They have the same denominator, so x squared minus x minus 20, x squared plus 2x minus 35. I know the denominator factors into x with a 5 and a 7. Positive 7, negative 5. Our numerator, I believe that's going to be 4 and 5. Before, at the very beginning of this, I said your success here depends a lot on you factoring. I wasn't kidding. Okay, it's everywhere. So negative 5, positive 4. In this case, the minus 5's cancel out, x minus 5's, and so we are left with x plus 4 over x plus 7. I haven't said this in a long time, but here x could not be negative 7 because that would make the denominator 0. So talking about undefined expressions, that's how we find it. What would make the denominator 0? Okay, these again have the same denominator, so I can just add those. 2x plus 2 over x squared minus 1. Now the numerator factors 2 times x plus 1, and the denominator is a difference of squares. So that allows for an x plus 1 to cancel out and leaves us with 2 over x minus 1. Again, where x is not equal to 1, because 1 minus 1 would be 0. Alright, so hopefully as you've looked at these, you've maybe found a mistake you've made, or you've done them right. But if you found a mistake you made, pause, go back, rework what you've got, make sure that it matches, that you understand what's going on here. Okay, next page. Add rational expressions with slightly different denominators. Okay, you notice we have a t minus 3 and a 3 minus t. We've used this little trick several times. We can introduce a negative 1. So that would be t squared over t minus 3, and I'm going to write the other denominator as a negative 1 times t minus 3. Now, these do not have the same denominator. But if you notice, we have a negative 3t, where's my pointer? Negative 3t right there, and a negative 1. So negative divided by negative would be a positive. So we can cancel out those two. And now we have the same denominator. Okay, so this would add as t squared plus 3t over t minus 3. Now the numerator does, it does factor. We get a t times t plus 3 over t minus 3, where t is not equal to 3. Okay, but that, I believe, is going to be our simplest expression there. Okay, so adding and subtracting. Make sure they have the same denominator. If they do, then keep it and add or subtract the numerators. Okay. Simplify to lowest terms if you can. Okay, using the idea of factoring and canceling. Okay, now what if they don't have the same denominators? Then we have to talk about the least common denominator. Okay. To find it, we'll factor everything and then take the product of all the unique factors. Okay, so let's look at some examples here. First thing you should notice is these two have different denominators. So what we need to do is make sure that they have the same. Well, this denominator has an a plus 3 in it. This one has an a. What would be really nice is if I could make this one have an a and make this one have an a plus 3. They'd have the same thing, right? Okay, that's the reasoning here. I'm going to multiply this by a divided by a, and this one by a plus 3 divided by a plus 3. So that gives me a 9a over a times a plus 3 plus an a plus 3 divided by an a times a plus 3. 1 times anything is just that. Now, if I combine these, now they have the same denominator. I'm leaving it that way. I'm not multiplying this out, by the way. Notice I'm not going to multiply this out because eventually I'm going to have to factor it anyways. But now I can add my two numerators to be 10a plus 3, and that is over a plus 3. And that does not simplify anymore, so that is my final answer. Alright, so let's look for the least common denominator with a couple of things. Well, I want them to have the same denominator. So with this one right here, 3/4 and 5 over x, I want them both to have a 4. I want them both to have an x. So the least common denominator would be 4x. Okay, number 2, I want them to have the same denominator. I have x squared and 6x. So the least common denominator will be having an x squared in there. That's the biggest number of x's we have, and also having a 6. So that is my least common denominator. That's what I would aim to have in both the denominators. Okay, number 3, I would want to have an x cubed, and I would want something that's in common between 4 and 3. And I believe 12 is going to be the least common multiple of those two, so that will be what we're after. Okay, this is where the whole idea of unique factors comes in. Okay, so if we look at 4, x plus 2x minus 2, the easiest way to make those two the same is to make it have one of each. They're two unique factors. Number 5, the same thing. We want y2, a y plus 4, and a y minus 3. Right, number 6, same thing there. We want a 3x and an x plus 3. Alright, so we've got a 2x and a 10x as our denominators. We want them to be the same. They both already have x's. Really, they both already have a 2, because 2 times 5. If I had a 5 over here, that would make it the same. So then 5 times 2 would give us the 10x we have there. So that will be 15 over 10x minus 2x plus 1 over 10x. They have the same denominators. Go ahead and add, or subtract in this case, over 10x. Okay, that leaves us with a negative 2x plus 14 over 10x. Okay, there's one problem here. That numerator simplifies. So I'm going to factor out a negative 2. That leaves me with an x minus 7 and my 10x. Now, the numbers cancel there. That leaves me with a 5, and that leaves me with a negative 1. So I get negative 1 x minus 7, okay, divided by 5x. Okay, so you try one. And I'll go ahead and tell you the least common denominator is going to be, once you factor this right here, that's x plus 2, x minus 2, our least common denominator is going to be x plus 2, x minus 2. That's what we want to have in both denominators. Right, so that means we are going to need to multiply by x minus 2 over here. Okay, so that gives me an x squared minus 2x over x plus 2, x minus 2, minus 8 over x plus 2, x minus 2. Combine those because they have the same denominator. It's plus 2x minus 2, x squared minus 2x minus 8. Now our numerator does factor. Okay, we have an x, we have a 4 and a 2, a negative 4 and a positive 2. And it appears that something's going to cancel the x plus 2. So our final answer is x minus 4 over x minus 2. Go back through each step. If you find something that's wrong, erase it, go back and work it again. Okay, next one I want you to try. Give you a second to do that. Okay, so our least common denominator is going to have an x and an x plus 3 in it. That's each of the factors we have in the denominators. Okay, so I will multiply my first fraction by x, and my second one by x plus 3. Alright, so that gives me an x squared plus 4x over x times x plus 3 minus 6x plus 18 over x times x plus 3. Now we have the same denominator, so I'll go ahead and subtract to get x squared minus 2x minus 18 over x times x plus 3. Now my numerator factors. So we have an x and x. See, to get 18, we have got 1 and 18, 2 and 9, that won't work, 3 and 6, 4, 5. I was pretty sure it was going to factor, but apparently it doesn't. Okay, it doesn't. So, unless I'm just missing something. So that will be our final answer. We got them with the same denominator. We combine them together. Nothing simplified, so that must be it. Okay, now I want to go ahead and factor this one before I try to find common denominators. Okay, so this one factors as x, actually let me do that up here, x over 5x minus 2 minus x plus 2 over, and let's see, a 5x leaves us with an x minus 2. And this is why I wanted to see what would happen when I factored it. My least common denominator is going to have a 5 in it, it's going to have an x in it, and it's also going to have an x minus 2. So the second fraction actually has our least common denominator in it. So what do I need to introduce over here to make that work? The only thing it's missing is an x. So I get x squared over 5x times x minus 2 minus x plus 2 over 5x times x minus 2. Subtracting those two, x squared minus x minus 2 over 5x, x minus 2. I believe that numerator is going to factor as a 2 and a 1. We will have a negative 2 and a positive 1. And then we have an x minus 2 that cancels out. So our final answer there is x plus 1 over 5x. Make sure you're getting tons of practice as you're doing these on your own. Okay? Alright, so a nice little summation. When you add and subtract, find the least common denominator. Find the least common denominator. Okay, and I physically actually write LCD is, okay, make sure you do that. Write each expression as an equivalent expression with that LCD. So multiply by whatever's missing to make sure that you have the least common denominator in every term. Then add and subtract the numerators and keep that denominator. And then, of course, simplify. Alright, so that brings us to the end of all of our rational expressions work. Okay, so if you have questions, of course, email me, ask me in class. Make sure we do those things. Alright, that's it.